Course 3, our second to last lesson. In lesson 119, we are dividing and simplifying with what we call a complex fraction, meaning we have a fraction on top of another fraction. Okay, and it's kind of confusing to look at, especially when you write it on paper where you don't have the advantage of colors like I do, and this is all one pencil color. It's going to be hard to keep it all straight, so I recommend using smaller fraction bars, what we call this, smaller ones here and longer and maybe even a little bit thicker ones here, so you can tell the difference between the fraction dividing the entire thing, right, versus this fraction bar is only dividing this part and then this one's dividing this part. Now a fraction bar, if we recall, actually there it is. Fraction bar is another way of saying operation is divide. Okay, so this means divided by. Okay, it means division. So we can read this really as 1/5 divided by 2/3. And if you remember, dividing by 2/3 really means multiplying by the reciprocal of 2/3. And the numerator was 1/5. That stays the same. So we go 1/5 divided by 2/3. And to do that, we go 1/5 times 3/2. Then we check, can we do any canceling ahead of time? Not this way, not this way. It's already simplest form. So we multiply across 3 times 1, 2 times 5. The answer to 1/5 divided by 2/3 is 3/10. What if we have an addition fact on each side? That's even more complex, right? We cannot, I just want to note, you cannot try and do anything like canceling like this, or, you know, I see a 3 and a 3, so you can't do that. Because these are being added, not multiplied. They're not factors, they're add-ins, so they have to stay where they are. This is really a grouping symbol. It's like saying, here's a parentheses, you got to solve this first, and here's a parentheses, you got to solve that first before you do the division. So what is 1/2 plus 1/3? We could multiply both of them by 6, but then we'd have to multiply the bottom by 6. So actually, I think we'd have to multiply everything by 12 over 12. And the book shows you how you could do something like that using a 15 in one of their examples. I think we already know how to solve these. Let's just do it the way we've learned. 1/2 is the same as 3/6, right? We're going to use the common denominator, 6. 1/3 is 2/6. So I would just say go with, all right, I have 5/6 on top. I have, looks like we're using 12ths here, so 4/12 plus 3/12 is 7/12 in the denominator, all divided. Again, I can use the color. You might want to use just a longer, thicker fraction bar. Now to divide, this is really just saying 5/6 divided by 7/12. That's really what this means. I'm going to get rid of everything else to focus us here. Now, how do I accomplish that? Remember the review. To divide by a fraction, we multiply by its reciprocal. Notice they've given us some canceling. Why don't we make this a little easier so we don't have to have 60 on top and 42 on the bottom? Let's just do 6 and 12 can both be reduced by dividing by 6. So we actually have 10/7. If we want to change that into a proper fraction, we could say 1 3/7, right? Right? What about a percent, a fraction percent? 28 and 4/7 of a 4/7%. All right, let's start with this part. We're going to want this as a improper. We're going to want to multiply 7 times 28 and add 4. All right? 7 times 28 is 196 plus 4 is 200. So we've got 200 over 7 is the same thing as 28 and 4/7. Now, what about this part right here? That's step 2. To find a percent, what we're really doing is dividing by 100 to get what is this number. So we go 200 over 7 divided by 100, which is really 100 over 1. So to solve that, we learn multiply by the reciprocal, right? Check for canceling. So we can divide these both by 100. It's 1/2. Multiply across, 2 over 7. 2/7. The directions on this one were to change the percent into a fraction. Have we done this? This looks like a fraction. So we've changed 28 and 4/7 into a fraction. What that actually ends up looking like is 2/7. Is it in lowest terms? Yes, because we did this part. Otherwise, you'd have some dividing. You'd have 200 over 700, and you'd have to divide that out, which isn't hard, right? If you hadn't canceled, you could have just crossed out the zeros later. But we've got that done already. Why don't you try lesson practice A through D, complex fractions.